Okay, so the race to build real, human-like AI, it's absolutely on. But here's the thing. All the big labs, we're talking Google, Meta, you name it, they're all kind of stuck on the same massive problem. They have to crack this one core puzzle before they can move forward. So what is it? What's the secret ingredient? What's that one skill that separates the AI we have today, which is powerful, don't get me wrong, from the flexible, creative, just human intelligence we all have? Well, it turns out the answer might just come down to a single, really powerful concept. And that concept, it's called abstraction. It's something you do without even thinking about it every single second of the day. It's how you can spot your friend's face in a huge crowd. You just ignore everyone else. It's how you know a chair is a chair, whether it's some fancy throne or just a simple stool. You instinctively, naturally, ignore all the details that don't matter so you can see the core idea. The billion-dollar question, of course, is how in the world do you teach a machine to do that? Well, there are three main paths being explored right now. And first up, let's take a look at Meta's really clever approach, which we can call the squint your eyes method. So here's the fundamental problem Meta's trying to crack. For a typical AI, the two images you see here, they're not two pictures of a car. To the machine, the pixels are totally different. You've got raindrops, sun glare, so it just sees two completely separate things. Meta's solution is kind of beautiful in its simplicity. You teach the AI to, metaphorically squint. You teach it to blur out all that distracting noise so it can focus on what's actually important. And here's how their model, which is called GPA, actually pulls it off. It's trained to intentionally ignore those fleeting details. The shadows that are always moving, the raindrops that are here 1 second and gone the next. By filtering out all that junk, it's forced to lock onto what's stable and consistent, the basic shape and form of the car. And the result? It learns the universal concept of a car, not just a perfect pixel-for-pixel copy of a single photo. So, when you boil it all down for Meta, the path to true intelligence isn't about seeing more, it's actually about seeing less. Abstraction for them is an act of subtraction. It's about learning what to ignore, deleting the noise to find the signal. Now, path number 2 takes a completely different road. This is Google DeepMind's recipe book method. This quote it hits the nail on the head. It perfectly captures the problem that DeepMind is obsessed with solving. So many of today's AIs, they are incredible mimics. I mean, they can memorize the answers to literally millions of questions, but they haven't actually learned the underlying math. You change the problem just a tiny bit and the whole thing just crumbles because they don't have that true understanding. So DeepMind's solution is to teach the AI the recipe for thinking. Instead of just showing it a million solved mazes, they teach it the actual algorithm, the step-by-step logic for how to get through any maze. And once the AI really gets that core logic, it can then apply that exact same recipe to a totally different problem. It could be a level in a video game, or it could be a super complex diagram of human blood vessels. The logic is totally separate from the data. So you see the difference, right? While Meta's whole approach is about deleting information, DeepMind's is kind of the opposite. For them, abstraction isn't about subtraction. It's about building this amazing toolkit of reusable logic, a recipe book, that you could apply pretty much anywhere. And that brings us to our third and final contender, the secret rule method. This comes from the Abstract Reasoning Corpus, or ARC project, which is led by Francois Chalet. This slide really gets to the heart of the matter. On one side, you have memorization, and on the other, real understanding. An AI today can look at the sequence 2, 4, 6, 8, and it'll correctly guess 10. But is it actually thinking, or is it just repeating a pattern it saw a billion times in its training data? ARC says real understanding is being able to figure out the underlying rule, the secret code, if you will, that creates that sequence in the first place, x equals x plus 2. Now, this method has a pretty technical name, program synthesis. But the test here is way harder. The AI can't just give you the right answer. It has to write a tiny little computer program that generates the answer. It has to prove it understands the rule by creating the rule itself. And in this way of thinking, the code is the abstraction. It's undeniable proof that it gets it. So for ARC, abstraction isn't about deleting noise, and it's not about reusing logic. For them, the ultimate test of intelligence is being able to find the hidden code, that secret rule that's governing everything underneath the surface. So, there you have it. 3 radically different philosophies, each one carving its own path up the mountain, but they're all climbing toward the exact same peak. This table really just lays it all out perfectly. You've got Meta with their squint your eyes method, which is all about deleting noise. Then you have DeepMind and their recipe book, which is all about reusing logic. And finally, you have Arc, arguing that real thinking is about finding the code. Deleting, reusing, or finding. Three totally different bets on what it really means to understand something. So while their philosophies couldn't be more different, they are all climbing that same mountain. Every single experiment, every failure, and every breakthrough, it's all just another step towards that one, single, transformative goal, true artificial general intelligence. Which, leaves us with one final, and I think really crucial question. As these labs are teaching machines how to think, what are the questions that we should be thinking about?